This is some of the software from my ground source heat pump. These are all the temperatures that I display every 45 seconds or so. The temperatures are in Celsius. This is the basement temperature. This is the ground floor air temperature. This is the ground floor temperature. This is the second floor temperature. This is the outdoor temperature, minus 2.7. This is the amount of electricity in watts that the heat pump is using. This is not actually a measurement, it's a model based on which pumps and compressors are on, but it's pretty accurate. These are the watts going to the basement, the watts going to the ground floor, the watts going to the second floor. Those are watts of heat. This is my coefficient of performance. This is the temperature of the water in the hot vat. It's being warmed up. This is the output of the hot vat. This is the water coming out of the hot vat. That pump is not currently on, so that's not meaningful. This is the output from the heat pump. It's not currently outputting any heat. This is the temperature of the cold water vat, water and glycerin, minus 9.7. This is the power in watts coming in from the backyard, 609 watts. This is the temperature, output temperature from the cold vat. So this is the temperature of the water glycerin mixture going out to the backyard holes, buried pipes, minus 5.8. And it comes back from the backyard buried pipes at negative 1.8 degrees. So it's been warmed up, in this case 4 degrees. I've got temperatures for the holes under the ground. Some of these are not very accurate. And I also have temperatures for this is a sensor above the compressors, this is a sensor inside one of the controller box, and this is the sensor inside the other controller box. And this gets refreshed every 45 seconds or so. I also have a camera. A video camera that I can turn on. You can see the indicator lights from the controllers, and you can see the temperature in Fahrenheit on the reader of the boiler. So even when the boiler is off, the water that's heated by the heat pump goes through the boiler, or goes out to the floors and then comes back and goes through the boiler. So that's essentially the return temperature in Fahrenheit. And then you can see at every hour I put out some hourly statistics where the average input power from the buried pipes, the output from the heat pump, the average watts going to the basement, ground floor, and second floor. Total output, in this case it's just over 3,000 watts. The energy used is 1152 watt hours for a coefficient of performance 2.62. The average temperature today so far has been negative 1.3 degrees. This is a model of the heat loss of the house. Different floors. This is the boiler run time. The boiler is not run this hour, but it has run today. It's used 93 cents worth of electricity for the gas, and This hour we used 11.5 cents of electricity, and for the last hour, the cost per kilowatt hour out is 3.8 cents. And you can see that I'm doing various things here. I'm turning the system pump. So the way I have it working now is the hot vat, which is VH, gets warmed up from 32 degrees. When it gets up to 54 degrees, as you can see here, then the pumps come on to pump the heat over to from the heat pump to the floors, and you can see that the temperature of the hot vat quickly diminishes down to 34 degrees, and then the pumps are turned off and it heats up again. But the pumping water through the floors continue to operate. If the temperature gets below my thresholds, then the boiler will come on at this point while the hot vat is warming up. The boiler will come on and give it a burst of heat during that interval, and then it will shut off. So it'll just warm everything up for a few minutes. And this is what's heating my house right now.